Hello, so for week 4A, I chose problem number 6, and it states, in New England, the horizontal component of the Earth's magnetic field has a magnitude of 1.2 times 10 to the negative 5 Tesla. An electron is shot vertically straight up from the ground with a speed of 4.3 times 10 to the 6 meters per second. What is the magnitude of the acceleration caused by the magnetic force? Ignore the gravitational force acting on the electron. So we're given, this is my image, and it's an electron being shot up from the ground, and B would be our magnitude, would be our magnetic field, and that is a vector that demonstrates the strength and direction of a magnetic field. The SI units for this is Tesla T. And then we are also wanting to know acceleration, a vector that measures the particle's charge of velocity due to time. Its SI units is meters per second squared. And then so I've included these two things in my image. And so since we know our electron's being shot straight up, normally with the right-handed rule, since it's being shot straight up, our B would be pointing to the left, but since it's an electron and it's not a proton, it's the opposite, so it's going east. So we know that it's going to be accelerating east, but we want to know how fast it's going to be accelerating to the, or how much is going to be accelerating to the east. And for this, I decided that our force equals mass times acceleration, which is just kind of what we learned first semester. And then I was able to fill in, we also know that force, from our magnetic force equation, that force equals QVB sine theta. And then so I plugged that in for force to equal mass times acceleration to be able to get our acceleration by itself. So what all these things mean is F is force, which is a vector that measures magnitude and direction, and this specifically is magnetic force on a moving charge particle. The SI units for this is newtons, which is demonstrated by an N. And then M is mass, and that is a measure of weight. Its SI units are in kilograms. And then A is acceleration, which I went over earlier, and it's a vector that measures the particle's charge of velocity due to time. Its SI units is meters per second squared. And V is velocity, which we were also given in the problem. Its SI units is meters per second. It is a vector that demonstrates how fast the particle itself is moving. And then B is magnetic field. It's a vector that demonstrates the strength and direction of a magnetic field. Its SI units is Tesla T. And Q is the value of point charge. Its SI units is coulombs, and we simplify that to C. So for this, I was able to know that we already know the general charge of an electron, the value of point charge, and that is 1.6 times 10 to the negative 19 coulombs. So I was able to just plug this into this equation, and then right here, that's our Q, and then our velocity is what we were given in the problem. It's 4.3 times 10 to the 6 meters per second, and then times our Tesla, which is our B that we were given in the problem also. And then for sine theta, this kind of just cancels out because we know we're perpendicular to the ground because we're going vertical. So we know it's a 90-degree angle. So our sine theta would just cancel out to become 1. And then our kilograms, I know that because just from looking up what is the mass of a singular electron, and that's always going to be consistent with all around. So I simplified this to get 8.2 times 10 to the negative 1 on top, and then 9.11 times 10 to the negative 31 kilograms on the bottom. And I divided those two things, and I got 9.06 times 10 to the 12th meters per second squared. And then that is our actual answer written out. So that is how much it's accelerating to the right.